All right, so this is continuing chapter 20, focusing on this idea of E cell and then its relationship to whether something is spontaneous, so related to delta G. So for this, you're probably going to need a highlighter, and you are going to have to find your formula sheet because I'm going to refer to the section on electrochem. There's going to be an equation that we essentially derive here that's going to be very important. So relating this all back to delta G and Gibbs free energy, if we have electrical energy, again, chemical change driving the electrical energy, we know electrical energy is equal to voltage times coulombs, okay? And we know the definition, which I gave you previously, is every volt is a joule per coulomb. So essentially what you have there is that cancels out the coulomb and you're left with a joule. So the energy difference, or the voltage that we see when we set up these cells, is always a relationship between the work, which is in joules, and the charge, which is in coulombs. And please remember that if I substitute in work, it is going to be a negative sign. That is because work is done by the system, is how we define it. So work is leaving the system, so that is why we always have it as negative. So the electrical energy is equal to negative work over Q, and Q is the symbol we use for charge. And I introduced that to you a long time ago, beginning of our discussions together. Q is the symbol we use for charge. So if I multiply Q times E, I will be left with negative work is equal to Q times E. Well, we have a new unit called a Faraday. And 1 mole of electrons is equal to a Faraday, because we need to kind of quantify this to a certain extent. And a Faraday is equal to so many coulombs of charge, 96,485. And this happens to be on your formula sheet in that section over here on the right. So that's a number you don't need to memorize. So if I go back to this idea, Q of charge, Q is going to be N, which is number of moles, okay, times a Faraday, okay, which is how many coulombs of charge. So if I take work as equal to Gibbs free energy, because Gibbs free energy is, again, the free energy available to do work, okay, I could substitute that in for W. Then I have Q, and then I have E. And I change the negative over to the right-hand side. So again, W is equal to delta G, so I have to move the negative. So what is Q equal to? Q is equal to N times F. So if I plug this all in, I have this equation here, which is found on your formula sheet, okay? Negative F NFE, okay? And that is the relationship between the cell potential is directly related to the free energy difference between reactants and products, So the E cell, you want it to be a positive value so that the delta G can be negative, meaning it's spontaneous. So if I go back to this equation here, okay, if my E is positive and this is an overall negative, it will always make delta G negative. Okay. Now, in terms of units here, remember G is usually in joules per mole. Well, N is electrons per mole. That's my N. My Faraday is equal to a coulomb. And my E, which is my E cell, is equal to joule over coulomb. So you could see that coulomb cancels coulomb, and essentially the electrons are canceled out as well. So what you're left with is joules per mole, which is your delta G discussion. So how do we use this? Well, it's a pretty easy formula to use. The only tricky part is understanding how many electrons are you really transferring. So find the delta G, and again, please understand that this is at 25 degrees Celsius, 1 atmosphere pressure for this to work. So my delta G is going to be equal to negative NFE. So if I go back on my notes, Okay, go back in my notes, and I find my this equation. So I purposely use something that we've already done. I get 2.12 as my voltage from this particular cell. So what I plug in here is going to be the following. So in this balanced equation, okay, how many electrons did I transfer? Well, it was a total of 2 electrons. So I could write down 2 electrons are being transferred from the previous problem. So I'm going to put a negative 2 moles of electrons times my Faraday, which is 96,485 coulombs per mole. And then my E cell is 2.12 volts. And again, that's positive. So therefore, when you multiply this out, it comes out to negative 4.09 times 10 to the negative, 10 to the 5th joule, or negative 409 kilojoules. Now, math is not the complicated part. Complicated part is recognizing how many moles of electrons are transferred. So you have to look at the balanced chemical equation and the net ionic equation to see how many moles are transferred. And then if it is a negative, this is considered to be a spontaneous reaction. So again, equating this all together, E cell is positive, that means it is spontaneous. And that is because of this equation, because then the delta G will always be negative, will always be negative. So what if I am not at 1 molar, okay? What if my concentration of my half cells is not at 1 molarity? Well, kind of equating this all together, if my delta G is negative, that means it's spontaneous, my E cell is positive. If my delta G is not spontaneous, it is a positive value, my E cell has to be negative. So if my delta G is 0, my E cell is 0, I have what we call equilibrium. So going back to the thermo chapter, I showed you this equation, okay? I showed you this equation, which is not standard conditions. So not standard conditions. And again, I did not focus on you doing the calculation. It's more for you to have a reference of where this formula that I'm about to derive comes from. And we just derived this equation, okay? What is the relationship between delta G and E? And again, this is on your formula sheet. So if I go to this equation here and I plug in NFE under non-standard conditions is equal to delta G at standard conditions. So I include the 0 there, the degree sign, plus RT ln of Q, okay? Then if I divide everything by negative NF, I have then essentially derived what we call the Nerst equation, okay? And the Nerst equation has many different forms. And again, it is going to be an equation that is useful. They don't require it on the AP test in terms of you doing the calculation. I'm going to have you do a couple of them, but I'm going to give you this equation, okay? So again, E cell, okay, minus RT over NF ln of Q, or E cell minus 0.0592 over N, the log of Q. So again, this is natural log, this is regular log. Or another one, I think this is the one that's in your book. The E cell under non-standard conditions is equal to the E cell under standard conditions minus 0.0257 over N. And again, this is going to be number of moles of electrons. Times the log of Q, and again, Q being products over reactants.